Lesson 6.6 is called Around the World, and basically we're going to look at application problems here, just a couple application problems. And if you read the little section that I've screenshotted into our sheet here from the book, it says many application problems are related to pi. Satellite orbits, the wheels of a vehicle, tree trunks, and round pizzas are just a few of the real-world examples that involve the circumference of circles. Here is an example from literature. I'll let you go ahead and read a little bit about Jules Verne and Around the World in 80 Days. Maybe some of you guys have read that problem. But in it, one of the characters is trying to get around the world, to navigate around the world in 80 days. So let's take an example related to that idea. You'll notice here that I have laid out our problems, particularly with the word problems, with the 4 steps already there. So I want you to remember, on every formula problem, for now until the end of the year, I want to see you show the formula, plug in your numbers, solve for the unknown, and give a final answer with a label. All right, and I'm reminding you of that by numbering these steps. Example number 1, if the diameter of the Earth is 8,000 miles, find the average speed in miles per hour. Phileas Fogg needs to circumnavigate the Earth about the equator in 80 days. So we're talking about a latitude at the equator. If you take different latitudes, then you're going to have a slightly different circumference that you are navigating around the Earth. But at the equator, we have the circumference of the Earth that we will be traveling. So let's take a look at our formula here. So circumference is equal to pi times diameter. So we're going to write that down. But notice that we're going to have to get an average speed in miles per hour as well. So actually, we're going to have a couple parts here. Let's think about the speed calculation. How do you get speed? How do you get miles per hour or meters per second? If you think about how those units are laid out, it gives you a hint. Miles per hour. That word per is basically a division. So miles per hour means you're taking the miles, dividing it by hours. Meters per second, you're taking the amount of meters traveled and dividing it by seconds. So our speed calculation, speed is equal to distance divided by time. That's how we calculate speed. So at the end of this problem, we need to calculate the speed. In order to calculate the speed, we need a distance and we need a time. Well, we actually already have the time. So if we think about speed is equal to distance divided by time, we know the time. It's given for us in this problem. It is 80 days. All right. Now, we can come up with another unit for time, but at the beginning of this problem, we have a time listed as 80 days. So what we really need is the distance then. The distance around the equator. Well, the distance around the equator is going to be the circumference of the Earth. So now we're going to go over and calculate the circumference. We are given that the diameter of the Earth is about 8,000 miles. So pi times 8,000 miles. Step 3 is to do any calculations that we need in order to solve the problem. We really don't have much in terms of work to do here. We can kind of skip down to step 4 and just reorganize this. So 8,000 pi miles would be our answer. Now, 8,000 pi miles might not mean a whole lot to some of you because we have left it in terms of pi. And so we could actually multiply that out and get a good answer for how many miles that is. It's a little bit over 25,000 miles, I believe. But since we are going to continue our calculation further, we want to keep our answer for circumference as exact as we can for as long as we can. So we're going to take that 8,000 pi miles and we're going to put it over here. And I'm actually going to put the unit on this one so we can really see that we are dividing not only the numbers but also our units. So 8,000 pi divided by 80. So if I do that calculation, I get speed is equal to 8,000 pi divided by 80 ends up as 100 pi. So basically just take this part right here, divide that, and then leave the pi kind of off on its own over here. So 8,000 divided by pi, I'm basically reducing that fraction to 100. So 100 pi, and then our unit is miles divided by days. So miles per day is what that speed actually is. Now, if we want to, again, multiply it out to get what the actual speed is, that would be 314 miles per day approximately if I multiply that out. So that's how many miles per day you'd have to go, about 314 miles per day. So approximately 314 miles per day. And you guys probably would rather have it maybe as a miles per hour because that's a very common unit that we use. So we already have the miles. Think about how many hours are in a day. So if we take our miles per day and divide it by 24 hours, so if we divide that by 24, we get approximately 13.1 miles per hour. And I could go through and do our little conversions that we worked on back in the beginning of the year. But I think we'll just leave it as 13.1 miles per hour and recognizing that I divided by 24 to get the miles per hour because there are 24 hours in a day. So however you want to think about that one, 100 pi miles per day, or 314 approximately miles per day, or about 13.1 miles per hour. That would be the speed. All right, example number 2. Wilbur Wrong is flying his remote control plane in a circle with a radius of 28 meters. His brother, Orville Wrong, clocks the plane at 16 seconds per revolution. What is the speed of the plane? Express your answer in meters per second. The brothers may be wrong, but you could be right. Hopefully you recognize that as a little bit of a play on words for the Wright brothers, who were the first people to get an airplane up in the air, the first ones to fly. In Kitty Hawk, North Carolina, if you ever get a chance to go to Kitty Hawk, North Carolina and see National Monument, memorializing them, it's quite a place. It's pretty cool to go. If you go there, stop at the Smithsonian on the way so you can see their airplane first, and then you can go down to Kitty Hawk, Outer Banks, North Carolina, and see where it all happened. Anyhow, let's go ahead and get the math done here. So once again, we have a speed problem. So speed is equal to distance divided by time. So we're going to have to get a distance and a time here. Now, we are given a time in this problem of 16 seconds. So speed is equal to some distance over 16 seconds. So that's our time for one revolution. All right, so when it says per revolution, what that really means is traveling in a circle. One revolution is one way around the circle, one time around a circle. So when we are talking about the distance in a revolution, basically we are talking about circumference. So circumference is equal to pi times diameter. Step number 2, plug in what we know. We are given that it has a radius of 28 meters. So actually, maybe I could go and use my radius version of this formula. So 2 times pi times radius. Or you could use the diameter version and just divide the diameter by 2 at the end. Or actually, we already have the radius here. You just multiply 28 by 2 to get the diameter and to use that. But in any case, circumference is equal to 2 times pi times the radius of 28 meters. So let's just clean this up a little bit. 2 times pi times 28 is going to be 56 pi. 2 times 28, and again, we're leaving it in terms of pi. So the circumference is about 56 pi, or it's exactly 56 pi meters. Okay, so now we have that circumference, which is the distance around the circle. So we'll plug that in now, 56 pi meters. And so speed is distance divided by time. So if I take and divide 56 divided by 16, that would be equal to 3.5 pi meters per second. Okay, so the 3.5 came from basically reducing this fraction to 7 over 2, and 7 over 2 is the same thing as 3.5, so 3.5 pi meters per second is the exact answer. Let's get it as a decimal though as well. If we multiply 3.5 times pi, or if you just take 56 pi divided by 16, that's going to be approximately 11 meters per second. And the abbreviation for meters per second is going to be an M over an S. So that would be meters per second. So that's our answer, 3.5 pi meters per second, or about 11 meters per second for the speed of the plane.